So when we started this whole shenanigans, we started by talking about what group you fit into. Did you fit into A, B, C, or D? And we went to all the different corners of the room. And then sometimes you might have fit into multiple groups. Sometimes you may not have fit into any group. All of that was getting us ready to talk about a function. And so right here we're going to finally give a definition for what a function is. So a function is a special relation. So if you made me define a function, I would say it's a special relation. So obviously I need to tell you what a relation is right now. Because if I start with this terminology, does anybody know what a relation is in math? That's okay. So a relation is just a collection of ordered pairs. It's a collection of ordered pairs. Okay, so let's say that I have 2, 3, -4, 5, and -6, -7. Very original. I don't know how I came up with those numbers. Okay? 2, 3, 4, 5, 6, 7. This would be considered a relation. It's just a collection of ordered pairs. What about on a graph? What does a relation look like on a graph? Well, I can just have a collection of ordered pairs. That would be a relation. All those points together. All right, what if I wanted to connect a bunch of points? Woo! Kind of looks like the Death Star. Okay. Here, is this a relation? Is this a collection of ordered pairs?
Yes.
It is. Every one of these is just a point on a graph. Right? It's just a collection of ordered pairs. So go back to what we're talking about. A relation is just any collection of ordered pairs. We can write it a bunch of different ways. So what makes a function different? Well, it's a special kind of relation. Okay? How special is it? Okay, it's so special because every input. You guys know what an input is? It's the value you put in. It's your input. For us in math, in a graph, which variable do we call our input variable? Don't know that? That's okay. X is considered the input. It has free choice. We can choose any X we want to, and we can plug it in. Plug it. You notice when I was working on the tables, remember I kept picking an X, plugging it in, finding out what the Y was? Because X was my input. I was putting X in. So every input, X, has exactly one output. And so which variable do you think is the output variable? Y. So again, this is not necessarily the definition that's on your paper, but this is my definition. If somebody were to come up to me and say, Mr. Coots, what's a function? I would say it's a special kind of relation where every input has exactly one output. So in our little example, A, B, C, or D, remember where we walked around the room, you were the input. You were the X. You got to choose what your output was. Sometimes, remember when I had Fort Payne, Alabama, USA? Your input fit into how many outputs? If you fit into Fort Payne, you fit into 3 outputs. You as an input had 3 outputs. That's not a function. You can only fit into one group. You can always go to one thing. Another way I look at it, whenever I think of a function, I think of a vending machine. That's always my go-to example. We as humans like things that are predictable, that are reliable, that do what they say they're going to do over and over and over. That's what we want. Who wants something that's unpredictable? Nobody. That's why you dump them. Okay, so what you're going to do, you want predictability. You want the same thing over and over and over. When you go to a vending machine, and this is really hitting home for me right now because I quit Cokes in August. But boy, I like to drink Coke. If I walk to that vending machine in there and I press this button, that's my input. What do I want to be the output? I hope it's Coke, right? There's a nice picture of a Coke can. So when I press this button, want to get Coke. Every time I press this button, I want Coke. This is my input, and I want a reliable output. The same thing every time. What if sometimes I press this button, and it didn't always give me the same thing? It'd stink. Yeah, I wouldn't be using that vending machine. That's what makes it not a function. There's unreliable. You don't always get the same output. All right. On the other side, it has to have exactly one output. What if I went and pressed this button and nothing happened? Did it have an output? No. So that would make it not a function. Or back in when I used to go to school here, and we used to have to go to a vending machine to get our drink for break. The Coke guy would put all the Cokes in, the Coke cans, Diet Cokes, and then there was always a button at the end that was just whatever he had left that didn't fit into the machine. And you could just press it, and you had no idea what you were going to get. Whatever was next. All right, so when I press this button, sometimes I get Coke, Dr. Pepper, Sprite. That's not a function because I want reliability. Every time I get an input, I want the exact same output. Do you kind of think you know what a function is?
Yes.
I kind of give you some idea. So what's a function? It's a special relation where every input has exactly one output. Different things here they want us to bring. Each element means every x is related to a y. We say that the function covers x. That means it relates every element of it. Some elements of y may not be related, and that's okay. What matters is every x has to have a y. And then exactly 1 means that a function is singled value. It will not give back 2 or more results for the same input. So here's our function notation that we looked at yesterday. What does this mean? If I input a 2 and I get out 7 or 9, it's not a function. Every time I input 2, I want to get the same output. So f of 2 could be 7, and that would be fine. And our y's will be considered our outputs. I think that y'all won't have very much problem doing this. Can you put ordered pairs in a table? I sure hope so. The ordered pair 2, 3 goes here. 2, 3. The ordered pair 4, 7. 4, 7.
That is so small.
And 6, 8 is 6, 8. Yeah, there may have been some way I'm supposed to be able to print that bigger, but I don't know. I'm still learning this new website. I'll try on the next one to see if I can make it bigger.
I hope I don't have to grab on there, because
Well, I mean, this is just your nose. If you need to draw your own graph, that's fine. I'm not taking this up. It's just notes for your future self. Okay, the ordered pair 2, 3 means from the origin. From here, what am I going to do? I'm going to go right 2 and up 3. Does everybody know that, how to graph? Do I need to explain that in more detail? So my point is at 2, 3. There's my point. Boom. Next is 4, 7. So now from the origin, I'm going to go right 4. That's 2, that's 3. I can't count. 4, up 7. 1, 2, 3, 4, 5, 6. I don't know. 1, 2, 3, 4, 5, 6, 7. Okay. Oh no. Work. That's close enough. Okay, then my last one here is at 6, 8. So here from the origin, I'm going to go right 1, 2, 3, 4, 5, 6, and up to 8. 1, 2, 3, 4, 5, 6, 7, and 8 would go right there in red. Leave me alone. Okay, so in my table, again, it's important to match them straight across, to graph them. It's very important to do X and then Y. But this last one, the tree diagram, we can put them in any order we want to, as long as we put all of our X's here and all of our Y's here. So I typically list my X's in order from least to greatest, and my Y's in order from least to greatest. So my X's go 2, and then 4, and then 6. And my Y's go 3, 7, and 8. And it just so works out this time that 2 maps to 3, 4 maps to 7, and 6 maps to 8. All directly across. Yeah. Any questions on the first one? All right, you guys try the next 4. Oh, one thing I forgot on the last one. So we made this relation. Is our relation a function? Does every input have exactly one output? 2 has only one output. 4, one output. 6, one output. So it would be a function. Because you see on number 2, I don't know if you can read it. It tells you to determine if that is a function or not. Is everybody finished with 2? Okay, does your graph look something like mine? Table, mapping. Notice how in my mapping I only put the X1 once. Even though I know 1 occurred 4 times, that's a singular input. No reason to list it multiple times. So is this a function? Why not? Yes, it is. Why is it?
Can't your x go to two different y's, but your y can't.
Okay, well that's what we got to get straight, right? What's our definition for a function?
An input that has exactly one output.
Every input, x, has to have exactly one output, y. So this is my input, 1. How many outputs does it have? 4. So this input has 4 outputs. Therefore, it is not a function. Is it a function? No. Not a function. Yes.
The first one's negative 2. You have it on positive 2. Your red dot.
Yeah, I was testing you guys. You passed. Good job. On 3, is this one a function? It is a function. Every input, x, has exactly one output, y. So that would be a function. And then 4, let's see, I've got x and y. I've got negative 2, 1, negative 1, 1, 0, 1, 1, 1. Negative 2, 1. Negative 1, 1, 0, 1, 1, 1. Negative 2, 0, 1. Okay, and here's the 4th one. Is this a function?
Yeah.
It is. Every input has exactly one output.